A ship the length of more than one football field just rose straight out of the ocean and stood there like it was standing on invisible legs. No wobble, no drift. Waves crashed below it and it did not move even 1 centimeter. This is not a movie trick. It is a real ship called the Ganghangping 5, and it was built to lift wind turbine parts so massive that no normal crane ship on Earth could handle them. We are talking about turbine blades longer than a football field, towers as tall as a 60-story building, and a crane that can hoist 1,800 tons nearly 200 meters above the water. If that sounds impossible, stick around, because by the end of this video, you will understand exactly how China pulled this off and why some of these turbines can power 55,000 homes from a single spinning rotor. If you like learning about wild engineering like this, smash that like button. It really helps this channel grow. And subscribe so you do not miss what we cover next. We are also going to look at the hidden dangers buried under the sea floor, the storm that almost wrecked an entire wind farm before this ship existed, and the computer brain that now runs the whole operation without a single person touching the controls. By the time we get to the typhoon section near the end, you will see exactly how this floating giant survives conditions that destroy regular ships. Let's start with the wall that stopped every other engineer in the world. The wall nobody could get past. For years, wind turbine companies kept building bigger and bigger machines because bigger turbines make more electricity from fewer parts. Fewer parts mean fewer ships, fewer cranes, and fewer trips out to sea. So size has always been the goal in this industry. But there was a wall nobody could get past, and that wall had nothing to do with the turbines themselves. It had everything to do with the ships trying to lift them. Once turbines passed about 18 megawatts in power, the parts became so heavy that regular ships could not lift them without tipping over. Picture a crane lifting a chunk of steel that weighs as much as a few hundred cars. Then picture that crane arm swinging out over the side of a ship floating on open water. The moment that weight swings out, the ship's center of balance shifts hard to one side. A small wave at exactly the wrong moment can turn the whole vessel into a giant seesaw, and that is genuinely dangerous when the load weighs hundreds of tons. Engineers in Europe and the United States basically agreed that 18 megawatts was the safe limit, and anything bigger was treated as too risky to even attempt installing at sea. Some companies spent years perfecting turbines right at that limit, instead of pushing further, because the ships available to them simply could not go any higher without serious danger. It became an unspoken rule across the whole offshore wind industry, almost like an invisible ceiling nobody wanted to test. So when China announced a turbine almost 50% more powerful than that limit, people across the entire offshore wind industry were stunned. The turbine itself was an incredible achievement, but here is the twist nobody expected. Building a record-breaking turbine was actually the easier part. Lifting that turbine onto a tower in the middle of the ocean, hundreds of kilometers from shore, was a completely different and far harder challenge. To get past that wall, China could not simply build a slightly bigger crane and call it a day. Engineers had to rethink the entire ship from the bottom up, and that decision led to one of the strangest-looking vessels ever built. Meet the machine that walks on water. The answer to this impossible lifting problem was a ship called the Ganghangping 5, delivered in August of 2024 in the city of Qingdao. At first glance, it does not look much different from any other large industrial vessel. It is 135 meters long and 50 meters wide, which is roughly the size of a city block, with a massive crane sitting on its deck. But its real secret is not visible until it reaches its work site. Hidden along its sides are 4 giant steel legs that can punch straight down through the water to the sea floor. Once those legs are firmly planted, hydraulic systems begin pushing the entire ship upward, lifting it clean out of the water like an elevator rising on 4 columns. After that happens, the ship stops behaving like a boat completely. Waves can roll right underneath the hull, and it will not tilt, drift, or rock even slightly, no matter how rough the sea gets around it. Engineers call this becoming a fixed platform, but in plain terms, it basically turns a 27,000-ton ship into a temporary island standing in the middle of the ocean. Most people who watch footage of this happening for the first time assume it has to be some kind of camera trick because a ship that size simply is not supposed to stand still on 4 thin legs while the sea churns below it. This matters more than it might seem at first glance. Cranes need a rock-solid, perfectly stable base to lift incredibly heavy objects with any kind of precision. You cannot hang 1,000 tons of steel from a crane arm if the ship underneath that crane is swaying even slightly with every wave that rolls past. A few centimeters of movement at deck level can turn into meters of swing at the top of a crane arm reaching 200 meters into the air. By lifting itself completely out of the water, the Ganghangping 5 removes the unpredictable ocean from the entire equation. Now, here is the part that should make you a little nervous if you knew nothing else about this process. Pushing 4 giant steel legs into the sea floor sounds simple on paper, but the ground hiding beneath the waves is far less predictable than anyone walking on land would assume. The hidden danger under the waves. The seafloor looks solid and dependable from the surface, but underneath that calm blue water, it is often anything but stable. Sometimes there is only a thin crust of hard-packed sand sitting on top of soft mud, loose silt, or even pockets of water trapped underground that nobody can see from above. When a heavy ship leg presses down expecting solid ground and instead finds one of these weak spots, the leg can suddenly punch straight through the crust and sink several meters in just a few seconds. Engineers in the offshore industry have a specific name for this exact danger, calling it leg punch through, and it has caused real documented accidents on support ships around the world. In some of these cases, one leg sinking unevenly created a dangerous tilt that forced an emergency evacuation of the entire crew before the situation became even worse. This is exactly the kind of hidden risk that could turn a routine construction job into a genuine disaster within moments. So the Ganghangping 5 was designed from the very beginning to avoid it entirely. The whole point of catching this problem early is that once a leg starts sinking unevenly, there is very little time to react before the tilt becomes severe enough to put the entire crew and the equipment at risk. That is why so much of the preparation for this ship happens long before it even reaches its destination at sea. Before the ship ever lowers its legs at a new site, a team of geologists scans the sea floor using sound wave technology and also takes physical samples by drilling small test holes into the seabed. This process tells engineers exactly what kind of ground is hiding beneath the surface long before the ship commits to standing on it. Then, as the legs actually begin lowering toward the bottom, an onboard computer system constantly monitors the pressure building under each individual leg in real time. If one leg senses that it is sinking faster or deeper than the other 3, hydraulic pumps instantly adjust pressure to keep the entire platform perfectly level. It works almost like the ship has 4 robotic feet, each one constantly checking its footing and silently correcting itself before a human would even notice anything was wrong. Once the ship is finally standing safely and steadily above the waves, the most dramatic part of the entire mission can finally begin. It is time to lift one of the heaviest single objects ever installed anywhere in the open ocean. Lifting a skyscraper-sized weight. The turbine this remarkable ship installs is built by a Chinese company called Dongfang Electric, and its measurements are honestly hard for most people to even picture clearly. The hub of the turbine, which is the central point where the blades connect, sits 185 meters above the surface of the water, making it taller than most skyscrapers that people walk past every single day without a second thought. The three blades together sweep out a massive circle 310 meters wide, which is large enough to cover roughly 10 football fields laid side by side. A single turbine built to these dimensions can generate around 100 million kilowatt hours of electricity every single year, which is enough to power roughly 55,000 homes, while also saving about 30,000 tons of coal that would otherwise need to be burned. To put that scale into perspective, just one of these turbines does the job that used to require building and maintaining a dozen smaller machines, which means fewer foundations need to be drilled into the sea floor and fewer ships need to make the long trip out to install them. That is part of the reason engineers were so determined to push past the 18 megawatt limit in the first place, because bigger really does mean better when it comes to long-term efficiency. To lift the heavy generator unit onto the very top of that towering structure, the crane mounted on the Ganghangping 5 has to hold nearly 1,800 tons of steel, almost 200 meters up in the air, suspended above open water the entire time. At that extreme height and with that much weight involved, even a relatively small gust of wind can create enormous force pushing against the crane arm, putting tremendous stress on the metal holding everything together. Engineers also have to deal with something most people would never even think to worry about, which is simple sunlight and heat. When the sun hits one side of a tall steel tower more intensely than the other side, the metal expands unevenly across the structure, and the very top of the tower can actually lean off its intended course by a few centimeters. In real offshore construction projects, this exact problem has forced entire teams to pause their work and literally wait for nightfall, allowing the metal to cool down and straighten back into its proper position before continuing the installation. On the Ganghangping 5, onboard computers track sunlight intensity, surrounding temperature, and wind speed constantly throughout the day, adjusting the crane's aim and alignment in real time, so these tiny invisible shifts do not end up causing expensive and frustrating delays. With this much steel, this much weight, and this much constant motion all happening at once, you might reasonably assume that something eventually has to give under the pressure. But this is exactly where the ship's overall design becomes genuinely clever, solving a problem that would otherwise make this entire operation impossible. Why the ship never tips over. Whenever the crane swings a heavy part out to one side of the ship, the entire vessel should logically want to tilt in that same direction, just like how a small rowboat tips over when someone leans too far over one edge. The Ganghangping 5 solves this potentially dangerous problem with something engineers call active ballast control. Hidden deep inside the ship's hull are large tanks that can be filled with seawater or emptied of it within just a few seconds, almost instantly shifting the ship's overall weight distribution. The very instant the crane shifts a heavy load to one side of the deck, powerful pumps move hundreds of tons of seawater to the opposite side of the ship, balancing everything back out before the tilt can become noticeable or dangerous. This entire correction happens automatically and continuously throughout the lifting process, so the platform always stays perfectly level, no matter which direction the crane happens to be pointing at any given moment. What makes this especially impressive is the speed involved. The crane can swing a load weighing hundreds of tons in just a few seconds, which means the ballast system has almost no time to react before the tilt would normally begin. Engineers solve this by having the system predict the shift slightly before it even happens based on the crane's planned movement, rather than simply reacting after the tilt starts. This whole operation, from constantly checking the seafloor beneath the legs, to balancing ballast tanks in real time, to tracking the sun's heat across the steel tower, produces far more data every single second than any human engineering team could possibly process by hand alone. That overwhelming flood of information is exactly why this ship runs on something most ordinary cargo ships simply do not have at all, which is a full self-operating computer system managing nearly everything happening on board. The smart system running the show. The Ganghangping 5 uses what engineers call an intelligent control platform, a system that manages the ballast tanks, the ship's overall positioning, and the crane operations all together as one single coordinated system rather than separate parts. This platform constantly reads real-world conditions like water density and wind strength, then automatically adjusts itself to save fuel, cutting overall fuel use by around 20% compared to similar ships that lack this kind of automation. Saving that much fuel matters a lot on a project like this, since the ship often has to stay out at sea for extended periods while moving between different turbine locations. Now, you might reasonably wonder what happens if a computer system this critically important loses its bearings or makes a serious mistake during such a delicate and expensive lifting operation. To prevent exactly that kind of failure, this ship runs 3 completely separate positioning systems at the same time, including China's own Beidou satellite network running alongside GPS and laser-based sensors, so that if any single system experiences an error, the other 2 instantly take over without any interruption. The navigation and crane control computers also operate on a closed network that never connects to the public internet at any point, meaning outside hacking is essentially impossible by the very design of the system itself. This kind of layered backup is common in other high-stakes industries too, like aircraft and spacecraft, where a single point of failure simply cannot be allowed to bring down the whole operation. And if anything were ever to genuinely go wrong despite all these safeguards, the captain standing on the bridge can turn a single physical key to instantly shut down all the automation and switch the entire ship over to manual hydraulic control within seconds. It is worth pointing out clearly that this automation does not replace the human crew at all. It simply removes the kind of small, exhausting human errors that tend to happen naturally after hours and hours of staring at screens and monitoring constant streams of data. Even with all of this advanced and carefully designed technology working together, there is still one opponent out there that pushes this entire system to its absolute limit, testing everything engineers have built into this remarkable vessel. Facing down a super typhoon. The South China Sea is home to some of the most powerful and unpredictable storms found anywhere on the planet, and offshore wind farms in this region have been damaged quite badly by these storms in the past. During Typhoon Yagi in September of 2024, extremely powerful winds caused serious damage to older wind turbines in the region, clearly showing just how violent and destructive these storms can become. Without warning, storms at this level can snap steel towers, tear blades apart, and shut down entire wind farms for months, while repair crews wait for calmer conditions before they can even reach the damaged equipment safely. So when a typhoon begins approaching a turbine that was installed by the Ganghangping 5, an automatic safety sequence immediately kicks into action without needing any human input at all. The turbine's 3 massive blades rotate so they face edge first directly into the oncoming wind, similar to turning a flag sideways so it catches far less air resistance, and this simple adjustment dramatically lowers the overall pressure being placed on the entire structure. Meanwhile, the ship itself uses its powerful hydraulic legs to lift its hull even higher above the rising water level, allowing large, dangerous waves to pass harmlessly underneath the deck instead of slamming directly into the ship and causing potential damage. This combination of a turbine that protects itself and a ship that lifts itself clear of danger means the entire system can ride out a storm that would have completely destroyed equipment built just a few years earlier. Once the storm finally clears the area and conditions return to normal, those same automated systems bring everything quietly back online, and the massive turbines start spinning again almost immediately, sending clean power back into the electrical grid without requiring days of manual repairs or inspections. From a ship that can rise straight up out of the ocean on command, to a crane that lifts skyscraper-sized parts safely through the open air, to a turbine that can survive a violent super typhoon without major damage, this entire project shows exactly what happens when engineers refuse to accept that something is simply too big or too difficult to build successfully. If this kind of engineering genuinely blows your mind, give this video a like, subscribe for more videos exactly like this one, and tap the notification bell so you never miss the next deep dive we publish. What part of this incredible ship surprised you the most? Let me know down in the comments below, and check out our other video covering the world's biggest wind turbines if you want to keep exploring this fascinating topic even further.